So user can actually use it to write something on the screen, right? And then things have changed over the time, and now what we have is stylus. So similarly, something like this we could use right nowadays, or like we can also use like separate what we call the tablet. We sometimes call graphic tablet. People use it this to draw graphics on the screen, and this will be a separate board, something you are going to connect through USB, and then when you write something in this pad, it will appear on the computer screen, right? So those are known as the lightweight. So as I told you, all these known as pointing devices. Then we have digital cameras. You already know that you can take photographs, videos, web cameras, and CCTVs. So these are basically cameras for different purposes. And this comes under what we call imaging and video input devices. So the cameras we can use to record images as well as videos. And then we will have scanners, and then in the scanners, there's a technology called optical character recognition, OCR. What it does, basically, in a printed document, using OCR technology, it can automatically recognize the characters, right? Let me quickly show you OCR, uh, how it works.
Behind on gold. So, it's pretty easy to take words and then but going into all that beautiful or up tones that corresponded to different letters, making it
Double converts print to write rhythm can be missing image. In an line works by identifying as a black pixels and visual character begins and ends. A matrix or white.
Right, there's a video that I would like to share with you.
Today we're going to take a look at OCR, or Optical Character Recognition. OCR is the technology that converts printed text into a digital format. The variety of different fonts and ways of writing a single character makes this problem hard to solve. Before an OCR algorithm can be chosen, the image must undergo some pre-processing. In this step, the document is straightened, despeckled, and converted from color to a binary image, an image where the only two colors are black and white. The feature detection algorithm identifies a character by analyzing the lines and strokes that make it. The second approach, pattern recognition, works by identifying the character as a whole. We can identify a line of text by looking for rows of white pixels with rows of black pixels in between. In the same way, we can identify where an individual character begins and ends. Next, we convert the image of the character into a binary matrix where white pixels are zeros and black pixels are ones. Then, by using the distance formula, we can find the distance from the center of the matrix to the farthest one. We then create a circle of that radius and split it up into more granular sections. At this point, the algorithm will compare every single subsection against a database of matrices representing characters with various fonts to find the character it statistically has the most in common with. Doing this for every line and every character makes it easy to bring printed media into the digital world.
So basically, as you seen, what basically it does, it's recognize characters. Usually, when we say OCR, optical character recognition, we talk about printed character, but now technology has advanced so that even when you write something on your hand, that means handwritten characters also can be recognized using this technology. Then we have barcode readers. I hope that when you visit shopping malls, we are computerized. We have barcode readers. That's actually pretty common nowadays. When you let me show you quickly some of the images. Right? These are the barcode written. And barcode is something similar to this one where we have a set of a number, put in some vertical lines like bars here. This barcode can be, read using the barcode reader, this machine. And nowadays we have QR code as well. In QR, actually, you can have a lot of information. Now, previous one, it's just the number it recognizes, but here you can even store address, or maybe you can also store web URL. Then MICR is, so about in finances, when we exchange money, so one form is we use checks, right? Checks are common method of payments between two parties. Now, there's a check number. You will see there's a number here that is we call check number, unique number, uh, which we can recognize using this MICR, or magnetic ink character recognition. So there are machines, especially if you visit to banks, so you will see that they will have something similar to this device, where it can actually read the check automatically and recognize the check number. And then we also have like ATM machines. So ATM machines also like recognize your credit or debit card, and connects to the bank accounts. And then we will also have what we call OMR, right? Especially in MCQ marking, right? So you know that in when you do O-level examinations, so your questions are automatically marked. Now for that, there are some devices we call OMR devices, or optical mark recognition scanners, are used to automatically mark your answers correct, right? So the basic idea is it recognize different marks. So this is quite useful, especially marking, MCQs. So all these we known as scanning devices, because it use some kind of a scanning technologies. So scanners, barcode readers, OCR, OMR, ATM, all these comes under scanning technologies. Then you mentioned this earlier, like microphone, we use to input sound and voice, and which this will conclude the input devices. And usually, given a particular device, you should be able to identify whether it's an input device, output device, or the storage, and so on. Okay, next, let's move on to output devices, right? Now let's look at output devices. In output device, right? First thing we are going to discuss is the monitor. Most commonly used output device is a monitor. Right, now let's take this. Now, if you take the monitor, the first thing we have to consider the size of the monitor, right? Now let's say this side is, let's say X, and this side is Y. And if I say I have a 32-inch monitor, which one we refer here? Is it X or is it Y? When we say my monitor size is 32-inch, is it X or Y, Dolina?
X.
Okay, Baki. Bagi, I can't hear you. Is it X or Y? When you say 32-inch monitor, or let's say TV, right? Tulin, it's neither X or Y. So usually, when you say 32-inch, we measure through diagonal, right? So usually we refer through the diagonal, not this. This is not used. This is also not relevant. So this is the size, right? Remember, now usually monitor sizes are starts from like 15 inch nowadays. Common ones are 17 inch, 18 inch. So various different sizes are there, but usually that will measure diagonally. So the screen size measured through diagonal, right? Make a note of this. And then we have different types of monitors, right? So early days we have CRT monitors, right? Cathode ray tube, especially some places still we use like our old TVs. We have this shape. So what you have here is a cathode ray tube, and since the monitor use that technology, we call CRT monitor, right? But these monitors actually consume a lot of electricity, consume a lot of power, and you need space. You know that size is big. Handling is a bit difficult compared to the newer versions. Now, after CRT, we have LCD, liquid display uh, monitors. So after CRT, we had LCD monitors. Again, compared to CRT, power efficient, and also you need less space compared to CRT monitors. And the newest one we call LED. The currently the latest ones we use is LED. The power consumption is actually really low, right? Power consumption is really low in LED monitors. Few things you need to remember about these devices, because sometimes in the questions they'll ask you to compare CRT, LCD, and LD monitors. As a CRT monitors, you need more space and it also consumes more power. But LCD, you need less space, less power consumption. It's expensive. You see that latest technology when it comes to that, it's expensive compared to CRT, and a slow response time. And likewise, LED monitor, you have better brightness and consumes again low electricity. Now, other than that, output devices, we have multimedia projectors, right? Multimedia projectors, especially in electronic presentations, we use multimedia projectors, right? Then we have printers. There are two types of printers, right? First of all, let me start with what we call dot matrix. Comes under we call impact printer. So there's a lot of impact is here. Now, for example, there it's very noisy, right? So there will be a ribbon and there's a set of pins, and it's actually hit the, these pins actually touches the ribbon, and it will generate a lot of noise, right? So you see that very noisy, right? Noisy printer, but the quality is a bit low, but the cost is very less, right? But if you take less printers, okay, first for line printer also impact printer.
Walsh with the Logic Group, and our company specializes in tracing solutions for the CNC and CAD industries. One of the big problems
and it spools from needle. Line feed. Yes, paper is feeding up line by line. We have a form feed. Yes, it jumps one entire form forward, and we have a micro button here. We can do micro steps to fine adjust our position on the paper. And that's interesting. I haven't probably jam between the plate and the ink ribbon. And when I go forward, it closes that again, so it does that automatically. You don't have to think of that. That's nice. Attention to detail. And start.
So you see here, that's also very noisy one, and it's quite faster compared to dot matrix. So dot matrix and line printers are considered as impact printers. So there will be an impact, there will be a printer head, and there are a set of metal pins that strikes on the ink ribbon, right? So the printout is, the cost is very, very low, like maybe a couple of cents, and it's very noisy. Cost of the printer is high, and low quality output again is low. Whereas there are another set of printers where we call non-impacting printers. Now laser, inkjet, bubble jet, thermal, plotter. So these are considered as non-impact printers. So there's no impact. Instead, you have different technologies are used in these printers. So let's quickly look at those things as well. So let's first start with the laser printers. So in latest printers, what will happen? There'll be a drum, and this drum is actually used to, attract the particles.
To fully understand how technically complex color printing is, take a look at the electrophotographic process. The primary charge roller, or PCR, rotates next to the OPC drum and applies a negative charge to the surface of the OPC drum, which prepares it for the imaging process. The OPC drum is then exposed to a laser, which forms the image. This area is more positively charged than the areas not exposed to the laser. Toner is stirred in the hopper. The toner adder roller collects the toner, moving it to the surface of the developer roller. The doctor blade then levels it to the precise height. As toner moves from component to component, it develops a negative charge, which is attracted to the more positively charged image on the OPC drum. The toner on the OPC drum is then transferred to the paper. This process occurs within the 4 color cartridges in every laser printer. The paper with the toner then passes through the fusing assembly, where it is melted and fused to the paper. Any toner remaining on the OPC drum is cleaned and moved to the waste bin by the wiper blade. The latent image on the OPC drum surface is erased by the PCR. Excess toner not transferred to the OPC drum is scrubbed from the developer roller surface by the toner adder roller and returned to the toner hopper.
Okay, so you see that the technology use, and then let's look at how inkjet printers work.
This is an HP thermal inkjet printhead. It prints a swath 4¼ inches or 108 millimeters wide. The ink drop generators are on 5 staggered silicon chips called die placed along the bottom. Each die is about an inch long and can have 2100 and even 4200 nozzles. So some versions of this printhead have 21,000 nozzles. HP scalable printing technology uses single die and multiple overlapping die to build printheads of different widths. The die are customized for inks and drop weights to meet the different needs of business, enterprise, commercial, and industrial printing applications. Scalability and high nozzle density are key features of HP's scalable printing technology. There are 2 groups of nozzles near the left and right edges of the die. Each group has its own ink supply, so the printhead can print 1 or 2 colors. With one ink, the 2 groups provide built-in nozzle redundancy for reliable quality and high-speed printing. A bead of epoxy at each end protects connections to electronic circuits on the die. Zooming in closer, you can see the left-hand group has 2 columns of nozzles. Let's cut away most of the die to look in cross-section at the area around 1 ink feed slot. The cyan region is filled with HP water-based ink. The wedge-shaped area is an ink feed slot cut through the silicon. It supplies ink to the nozzles. The printhead's electronic and fluidic components are built on a silicon substrate, shown in gray. HP builds thousands of identical nozzles and chambers on each die. A high-resolution optical process used with light-sensitive polymers produces features with integrated circuit precision. When generating drops, the nozzles in the 2 columns fire in a sequence that minimizes fluidic interference. Let's take a closer look at a drop generator. So you can see inside, we've made the nozzle plate and cyan ink transparent. 3 walls surround a heater resistor on the silicon, and the chamber is open to the ink supply through a restriction. 2 pillars prevent particles from clogging the chamber and nozzle. The nozzle is filled with ink, and the meniscus is the surface where the ink meets the air. A human hair is thicker than the chamber and nozzle together. The clock shows time in microseconds. The resistor heats the ink or 33 feet per second. The gap between the printhead and the paper is about 1 millimeter. The flight time is about 100 microseconds, and by the time the drops arrive, another vapor bubble could have grown and collapsed to produce another drop out of this nozzle. Here, the paper is shown moving under the printhead at about 200 feet per minute, or a little over 1 meter per second. The elapsed time on paper is shown in milliseconds. Drops of water-based ink sit on the surface of plain paper before absorption begins. Paper surface chemistry and coatings affect how long this takes. The ink now wets the surface and spreads out to form a dot. Ink is made from a colorless ink vehicle and a colorant, which is a dye or pigment. With HP pigment inks, pigments remain near the surface to produce a durable image with dark blacks and vivid colors. As it is absorbed, the ink vehicle binds the pigments to the paper. This HP inkjet printhead.
So in this case, you have seen in inkjet printers, you have ink droplets we used, and it forms a dot and shows you here. And then we have thermal printers nowadays. Now, for example, if you go by bus and sometimes you'll see the conductors, they are having small printers where they issue tickets. Now, for that, they will use what we call the thermal printer. So the thermal technologies you use. For example, this is a cable printer. What you see is
Thermal printing is a digital printing process in which material is applied to paper or some other material by melting a coating of ribbon so that it stays glued to the material on which the print is applied. How to change roll in thermal printer. These are the rolls that we are going to replace. Remove the existing one. This just slides open and adjust the another one. Now your printer is ready to use. How to print barcode labels by using thermal printer. We have designed this barcode label by using the RPU barcode label maker software. Go to print and adjust printing settings. Click on print button. Here your barcode labels are printing.
so in thermal printers, we use heat compared to the other two technologies. And finally, we have plotters. So especially in the drawings, so we will use plotters. Plotter will be like other. So you see that when it comes to printers, uh, first of all, we can categorize as impact printers and non-impact printers. Under that, we have seen impact printers. We discuss dot matrix printer and line printer, which are noisy printer, as well as their cost is quite less. The printer, the output printout cost of a printout is less. Now, when it comes to non-impact printers, we have laser printers. If you are aiming for higher quality, then you have to select laser printers. But if you want to minimize the cost of this, then we can go for inkjet. The thermal printers are quite popular nowadays, and the plotters are special printers we use, especially in CAD drawings and so on, right? Now, another thing that you should know, given a application, you should be able to identify which printer works best. Now, for example, for hospital, what kind of a printer you are going to suggesting? Are you going to suggest impact printer or non-impact printer? Dulina?
Non-impact printers.
Yes, it should be non-impact printers because noise will be the problem when it comes to a hospital. So maybe we can go for low noise printer like laser printer, right, compared to dot printers. If you take a school, for example, Bhagya, which kind of a printer you are going to recommend?
Impact.
We can go for inkjet. Let's say we want to allow students to take as many copies as they want.
Impact printers.
Yeah, like dot matrix, what would be better for a school if you think about the cost of the printout, right? Okay, so likewise, you should be able to identify like what printer types you might need different applications. And the next one is the speakers. I know you already know. So when you want to output music and the sound, we use speakers for that. Right. Now we have completed discussing the input devices as well as output devices. The next thing we can look at is central processing unit or CPU, right? If you remember, we had three parts. We have control unit, arithmetic and logic unit, and memory registers. Control unit is the place where it controls everything. The flow of data is actually controlled by the control unit. And arithmetic and logic unit, or in short, we call ALU, is the purpose of when the computer will perform any arithmetic and comparison logic operations. It goes inside the ALU. And then we have memory registers, very small memory locations. Whenever CPU needs data for quick access, we have to keep them inside memory register. So that part I think we have already discussed. Then the speed of the computer, right? Now, when you look at the purchasing a computer, one of the main things you have to consider is the speed of the computer, or which we call the processor speed. Right? So when you say processor speed, sometimes also referred as clock speed or clock rate, which will give you an indication how fast the computer is, right? Now, for example, if you take number of calculation, a computer can perform within one second, right? So we can use hertz. That means number of clock cycles per second, or else you can go for 1 million. We call megahertz, and or in billions or 1,000 million, right? We call gigahertz. Now the symbol is hertz. The conversion goes like this: 1,000 hertz is equal to 1 kilohertz. 1,000 kilohertz is equal to 1 megahertz. 1,000 megahertz is 1 gigahertz. Right. So that's how the computer speeds are measured. Dulina, a small quick question. If you take, let's say you are going to purchase a computer today, what kind of speeds available nowadays? Do you know like the speed of a typical computer? Yes, Dulina? What is the speed of your computer? So if you go to the start button and let's say computer management, no, it's not management. If you go to this place, this window, right? So here you can actually see the details of your computer. Now, for example, this is the place where it talks about the speed of the machine, the processor. It says Intel Core i7 and the speed is 1.8 gigahertz, right? So that's the speed it operates. So you see the typical computer, fastest one, you can go up to, let's say, 3 to 4 gigahertz for the time being. So that measures the speed of the computer. Right. The next thing is we would like to discuss the memories. Now, right now we discussed there's a very small memory inside the CPU, right? We call memory registers. But when we work particularly with the computer system, the primary memory or main memory, in short we call RAM, is there to store whatever the data needed for the CPU. But it's a temporary one because when there's a power goes off, then whatever the content inside the RAM is also goes off, meaning like erased. So which means as far as the power is there, the RAM can hold any data items, but whenever the power goes off, then nothing will remain inside the RAM. So that's called RAM. Usually in the motherboard, you will see this RAM. So usually in a motherboard, this figure actually shows you motherboard, and this is RAM, right? This is what we call the RAM. But there's another one called ROM, right? It's called read-only memory, and usually the read-only memory it consists of the data you need to start the computer. When you switch on the power, there'll be a one BIOS we call basic input and output system, which will actually check the contents within the system, whether they are working, and if so, then it will direct it to the Windows operating system. So usually ROM is there, right? So BIOS or ROM, we call it now here, the place where we have the ROM here, the BIOS, right? And that is place where we store this. So here you will see ROM chip is there, right? So which is permanent. So when you talk about these memories, so here is the ROM chip. Here we have the ROM chip, and here we have yes, the keyboard, sorry, motherboard, and then we have the ROM chip is there. So let me show you. So here we have ROM chip, where we have the information you need to start the computer. Right. So that's about the different types of memory. So right now we have discussed RAM and the ROM. So usually the read-only memory is there inside the chip, and that's what we have the commands for BIOS. There's another memory comes in when you talk about the memory. It's called cache memory. Now, before we get the data inside the central processing unit or CPU, right? So there'll be another memories between CPU and RAM to keep whatever the information needed by the CPU, right? Now, for example, when CPU needs some data, it will first look at cache memory. If it is there, then it will use that data. If not, then it will go to the other level, right? So that means you go to RAM. So as you can see, we can divide the computer memory as primary memory or RAM or secondary memory. Sometimes the hard disk, for example, we can use as a secondary memory, right? So the we call it in signal. And then the primary memory, we can further divide as random access memory RAM, read-only memory, and cache memory. Now, if you go back to a machine configuration, so let's go to a place where it's a single. Let's say I'm going to purchase a laptop or something. Right? So I'm going to select a particular product from here. So let's say I'm going to use tablets. Okay, laptop. So let's say I'm interested on purchasing a laptop here. Right, you see there are a lot of laptops are there. So let's look at the configuration. So let's select this one. And then if you go inside the specifications, right? So let me see whether we could find the specifications. Right, here we can see specifications. It's actually gaming laptop and it's for the gamers. And then it uses G5 Ryzen AMD processor. And then you will see the display size is 15.6 inch. We know how to measure the display size is. And then if you take the processor speed, it doesn't say exactly the speed here. Maybe we could look at a normal machine. Yes, in this one, if you go to specifications, you will see, right? Again, it didn't say exactly the speed is. Okay, so it goes to 6. Okay, so it's there. So in this machine, it's there. It's say up to 4.2 gigahertz. Processor can go up to 4.2 gigahertz. That's the speed of the processor. And the RAM, when we talk about the RAM memory, that's the RAM we specify here, it will be a 4 GB RAM. Right. Now, I told you sometimes when the RAM is not enough, we will use secondary memories. Secondary memories are nothing but the other storage media, like media devices, hard disk, floppy disk, as well as tapes. Optical disk drives such as CD, DVD, and Blu-ray, and solid-state devices, SSDs, like USB flash. So those are called secondary memories, like basically storing what these are like. We can consider them as external storage. Now, when you compare the speeds, now we discuss multiple memories now. I told you within the CPU we have registers, and then in between CPU and RAM we have cache, and then we have a RAM and then hard disk. The speed is registers are the speeds, and then the cache, then RAM, then hard disk. But if you look at the capacities, it's the other way around. Registers have the smallest capacity, like a couple of kilobytes, and cache are usually a couple of megabytes, RAM couple of gigabytes, now hard disk in terabytes, right? So the capacities are increasing, and you will see the same even in this the document as well. So it says 8 MB cache. The cache memory size is 8 MB, and then storage is 1 terabyte, and then the memory is 4 gigabytes. Right. So that's about the speed of the memories as well as the capacities. So you should remember these. Which one is the fastest? Which one has the largest capacity and so on. And there are typical numbers I have put. These are not necessarily the correct values, but I think very close to the average. Average, the capacities. Now, if you take a hard disk, you can go from 256 gigabyte to now we have 4 terabytes, and then usually you have one. Then we have floppy disk. Before hard disk came into picture, what people have used is what we call this floppy disk. Floppy disk actually came with different sizes, and this is the last one that we have seen, right? If you see something like this, so floppy disk could be used. The size of the floppy disk and then CD, you already know the CD size. Normally you will have about 700 megabytes, but it can go from 650 to 900 megabytes. Then we have DVDs. DVD size generally it's 4.7 gigabytes, but if it is a double layer, then you can go up to 9.4 gigabytes. Blu-ray disc, it's not that popular nowadays, but still you can store 25 GB to 128 GB. Then pen drives about 4 GB. You will also have 9 GB, 16 GB, and so on. And even the same memory card, SD card also we have 6 gigabytes. So these are the rough, measurements of different storage capacities. Right. Next, we have to talk about the motherboard. We already know motherboard. It will connect everything together. Like the motherboard is the one actually connects everything together. Right. There are different what we call the ports are there, and using ports we can actually connect a lot of devices together, right? And definitely motherboard is one of the main physical device in a computer system, right? So when you look at a CPU and outside of the CPU, usually we will see something like this. Let me open a new tab. So you will see something like this. I told you motherboard is one that actually connects a lot of devices together. Now how it actually connects using these ports. Now you see this port. I hope it's familiar to you. These ports are known as PS2. Right, and then we have USB ports. You can actually connect multiple devices using USB ports. And for networking and internet, we can use Ethernet, or we can say RJ45. Then early days for printers, we have used parallel ports, and the communication port we will use, and then VE port we will use. And then we have microphone, lighting, speakers. They are different. And then, right, so this is another what we call the MIDI port. I do not think you have to remember that, but this thing you should remember what those are. Right. So if I go from the beginning, PS2 port we have already seen. You can connect to a keyboard and mouse, and purple color we use for the keyboard. And then we have parallel port. Especially this is used in early days to connect printer or a scan. The very recent one, when you call the graphic ports, we will use HDMI. So when you search for HDMI, you will see the port, and sometimes you may already have the port with you, right? So these are some of the HDMI ports. Then we have network port we call RJ45. So when you take RJ45, this is the port we will expect it. So for example, if you want to network computer together or making a printout, so you can use Ethernet port to communicate with one of the devices, right? Okay. Then audio ports, jacks are there, so that you already know. And then USBs are quite common nowadays. The USB are quite popular because it has the highest data speed, data transfer speed, we call it. Right? And then video port, you already know, we use to print, monitor, multimedia, or projector. And serial ones are usually in the external modems as well as serial mouse. Early days, people have used serial port, but nowadays most of the computers you nowadays don't see these ports are there. Nowadays we don't have parallel port, serial port, and now even the VGA is going to be will not be used. Right. So let's look at the advantages of USB because it's used for many devices. You can connect keyboards, mouse, scanner, printer, various devices you can actually connect using USB ports. So one advantage is whenever you connect something, right? When you connect devices USB, so you don't have to install sometimes software. We call it's plug and play because you don't have to install the software, system automatically detects it. And then sometimes in some machines, the electricity taken by the USB port, right? And then it also has high data transfer rate. Right? So these are the advantages of USB ports. Right. Okay. We'll have a small break, 5 minutes, and then we'll continue with the data communication part. The receiver as the destination. Right? So we can say that in one side, those who actually send data, we can say sender or source, and those who receive the other side, we can say receiver destination. And there should be some form of medium should be there for this transmission, right? So when you say the basic component, so remember we have to have three. Now let's take you are making a phone call to your friend, right? Can you tell me who's the sender, who's the receiver, what is the medium? Dulina? You are making a phone call to your friend. I want you to identify the basic components.
The sender is me.
Yes, send is me.
Receive is the friend.
You receive is your friend.
And the source
You use
is
the telephone.
transmission is telephone. Yeah.
Maybe let's assume in that you have phone line. Maybe that's what you are going to take it as a medium. Right? So we can say the source is me and the receiver is friend and then the telephone. I hope you got the basic idea. Now, when we talk about the data transmission, depend on how data transmit, we can divide this transmission into three modes. The first one we call simplex, meaning like it goes from one direction, right? Now, for example, think about radio and television communication, or we call broadcasting. We say broadcast because in only one side, right? Now we get the signals, we get the the television from one side, isn't it? So this will be a one side, so that there should be arrow in this side. We call it should be in one direction, right? So if the data transmit only one direction, then we call simplex. So we can say data always travels from data source to data sink or sender to receiver. If that is the case, we can say simplex. Now the second one we call half duplex. Half duplex means the data transmission happens both sides. Now you see the in the arrows in both directions, but not in the same time. Now, for example, have you seen walkie-talkies?
Yeah.
Yes, the police sometimes they use what we call the walkie-talkies. So it will be a one direction. That means a particular person can talk at one time, and then the other person has to take. You take turns, right? So what happens when you have two parties? A given time, one person will be a sender, the other one will be a receiver, and the next time that person will be a sender, and then the other person will be the receiver, right? Both sides. This is very similar to even the internet browsing is, because internet browsing means you made the request to a web server, so that means in one direction, and then you will get the data another direction, right? And it will not happen at the same time. So we call half duplex. And the final one we call full duplex. The data transmission happens in both direction, and then it's like it happen in the same time, right? Now, for example, let's say someone is scolding at you, right? So you can go for half duplex, meaning like the first person actually scolding you, you listen, and after that you start scolding him, let's say. That's called half duplex. Or you can scold each other at the same time. We call full duplex, right? So if this is happening, so we call full duplex. If you take telephone conversation, so it becomes full duplex, right? So these are called the transmission modes, right? So the three things we have discussed, so that simplex, half duplex, and then full duplex. The next one is transmission medium. Right now, we discuss sender, receiver, and there should be a medium. And that could be a wired medium, we call guided medium, or wireless. Now, for example, if you have a fixed phone, right? Telecom, if you have the fixed phone, fixed line, then it's, it's a wired one. And nowadays mobiles work with the wireless. So different technologies are using. Now, when we say guided media, the first one we call twisted pair. Now, when you take network cables, we call twisted pair. We call twisted pair cables. So let me quickly show you an image. So that means there'll be, two different types of cables are there. Right? So let me open image in the new tab. Okay, so in this one, for example, right? So this is twisted pair. There'll be a copper wires, right? And then it's twisted. So because of that, we call it a twisted pair, right? And then in twisted pair also you have two types. We have unshielded twisted pair and shielded. We call STP and UTP, right? So we can say UTP and STP. So you will see here in this image, for example, let's say, so there has to be a separate shield. Now here is a UTP unshielded without any separate shield. With the shield, we have STP, right? So we have UTP cables as well as we have STP cables. That's the first one. And then we also have what we call coaxial cable. Traditional, antenna cable. I don't know whether you are now right now using the coaxial cables. If you take traditional antenna cable, so it's look like this, right? So you'll be having a middle wire, and then you have a copper mesh, and within that you have insulation. So something similar to this one. Since it's the the cable as well as the mesh is around the same axis, we call coaxial, right? Coaxial cable. We call coaxial cable. Right. So, one is twisted pair. There are two types, UTP and STP. And then we have coaxial cables. And finally, we have fiber optics. We have fiber optics. Yes, if you take fiber optics. In here, actually, slightly different. You use light to transmit data, right? Lighting we use, lighting we use to transmit data compared to previous one. The quality is high, the data, but then it's really expensive, right? So the cables are really expensive. Now the second one is actually unguided or wireless transmission media. Then, I hope you are familiar with the Wi-Fi and Bluetooth technologies. They use radio waves for this. Then for a long distance, we will use microwaves. And if you take keyboard and mouses, we have infrared. So these are called wireless transmission medium. Okay, I think we'll stop for today, and then I'll be sending some handouts, and also I shared a paper. If possible, you can try the MCQ and send it to me. Okay, so let's meet in the next week. Dulina S5. So we'll stop for today.